In this work, we propose a deep learning framework for structure from motion, which estimates both depth maps and camera poses for multi-view inputs. For example, from a video or multiple images of a scene. Conventional approaches heavily rely on bundle adjustment to optimize the 3D geometry and the camera poses by minimizing reprojection errors on correspondences. However, these methods typically fail to reconstruct reflective, textureless, or transparent surfaces due to the missing of correspondence across views. In the era of deep learning, early structure from motion methods directly regress the depth values and camera poses, and they usually have extremely poor generalization capability. Recently, cost-volume-based approaches explicitly calculate consistency among visual inputs on a set of depth hypotheses and achieve the state-of-the-art depth accuracy. However, they usually assume non-camera poses, whereas their deep learning approaches can predict both depth and camera pose while achieving reasonable generalization capability. Inspired by traditional BA, we propose a deep learning framework that refines depth values and camera poses alternatively. In each iteration, we build cost volumes to verify both photometric and geometric consistency. One of the major performance gains is achieved by estimating camera poses by building a cost volume to explore the pose hypothesis space. Our method shows comparable or better performance on several popular benchmarks compared to the SOTA method. More details about this work can be found in our presentation and paper.